Introduction to Biology, Part 5. The question of how life originated is not easy to answer, because it is impossible to go back in time and observe life's beginnings. Nor are there any witnesses. There is a testimony in the rocks of the earth, but it is not easily read. And often it is a silent on issues crying out for answers. There are at least three possibilities. First is a special creation, second, extraterrestrial origin, and third, spontaneous origin. Special creation. The theory of special creation, that the divine God created life, is at the core of most major religions. The oldest hypothesis about life's origins, and is also the most widely accepted. Far more Americans, for example, believe that God created life on Earth than believe in the other two hypotheses. Many take more extreme position, accepting the biblical account of life's creation as factually correct. Extraterrestrial origin. The theory of panspermia proposes that meteors or cosmic dust may have carried significant amounts of complex organic molecules to Earth, kicking off the evolution of life. Hundreds of thousands of meteorites and comets are known to have slammed into the early Earth, and recent findings suggest that, at least, some may have carried organic materials. Nor is the life on other planets ruled out. For example, the discovery of liquid water under the surface of Jupiter's ice-shrouded moon Europa and suggestions of fossils and rocks from Mars lend some credence to this idea. The hypothesis that an early source of carbonaceous material is extraterrestrial is testable, although it has not yet been proven. Indeed, NASA is planning to land on Europa, drill through the surface and send the probe down to see if there is a life. Spontaneous origin. Most scientists accept the theory of spontaneous origin, that life evolved from inanimate matter. In this view, the force leading to life was selection, as changes in molecules increased their stability and caused them to persist longer. These molecules could initiate more and more complex associations, culminating in the evolution of cells. Panspermia and spontaneous origin are the only testable hypotheses of life's origin currently available. The Miller-Urey experiment, an early attempt to see what kinds of organic molecules might have been produced on the early Earth, was carried out in 1953 by Stanley L. Miller and Harold C. Urey. In what has become a classic experiment, they attempted to reproduce the conditions at the ocean's edge, under a reducing atmosphere. To carry out their experiment, they as first assembled the reducing atmosphere, rich in hydrogen and excluding gases oxygen. As second, placed this atmosphere over the liquid water, which would have been present at the ocean's edge. As third, maintained this mixture at a temperature somewhat below the 100 degree. And finally, they simulated lightning by bombarding it with energy in the form of sparks. They found that within a week, 15% of the carbon originally present as a methane gas had converted into other simple carbon compounds. Among these compounds were formaldehyde and hydrogen cyanide. These compounds then combined to form simple molecules such as formic acid and urea, and more complex molecules containing carbon-carbon bonds, including the amino acids glycine and alanine. Amino acids are the basic building blocks of proteins, and the proteins are one of the major kinds of molecules of which organisms are composed. According to this experiment, molecules that are the building blocks of living organisms form spontaneously under conditions designed to simulate those of the primitive Earth. Scientists disagree about where life started. While most researchers agree that life first appeared as the primitive Earth cooled and its rocky crust formed, there is a little agreement as to just where this occurred. If life didn't originate at the ocean's edge, under the blanket of the reducing atmosphere, where did it originate? One hypothesis proposes that life originated under the frozen ocean, not unlike the one that covers Jupiter's moon Europa today. All evidence suggests, however, that the early Earth was quite warm, and frozen oceans quite unlikely. Another hypothesis is that life originated deep in the Earth crust. In 1988, Gunther Wachterhauser proposed that life might have formed as a byproduct of volcanic activity, with iron and nickel sulfide minerals acting as a chemical catalyst to recombine gases, spewing from eruptions into the building blocks of life. Becoming more popular is the hypothesis that life originated at the deep-sea hydrothermal vents, with the necessary prebiotic molecules being synthesized on metal sulfides in the vents. The positive charge of the sulfides would have acted as the magnet for negatively charged organic molecules. In part, the current popularity of this hypothesis comes from the new science of genomics, which suggests that ancestors of today's prokaryotes are most closely related to the bacteria that live on the deep-sea vents. So these are scientific theories about the place where the life originated. Hi, I'm Andrew Massey. I hope that you found something interesting in these basic biology tutorials, and also learned a bit about the tremendous facts that create my, your, and everyone's world.